This browser FPS came from a local Qwen model. You can move, aim with the mouse, shoot enemies, take damage, manage ammo, and restart after game over. It also tracks score and kills across 3 waves with a separate victory state. But the first build stage ended with a 16,000 ring barrel token response, no tool call, and no source code change. We used the Unsloth-distributed Qwen3.8-27B parameter Q8 GGUF together with its BF16 vision projector. It ran in llama.cpp build 10438 on 3 RTX 3090s and 1 RTX 4090. This was a single local pilot with 1 agent, MTP turned off, and no human rewrite of the generated game source. The first build stage lasted about 10 minutes and 20 seconds across 3 model turns. On the final turn, the response hit the 16,984 token limit without making a tool call. The 3-turn stage left the source unchanged, a long response, but no game. This screen reconstructs public safe saved events. It is not original run footage. After preserving that failure, we tried 4 recovery turns. They ran for about 13 minutes and 55 seconds, but the attempt was interrupted before the 262K continuation. We then restarted the server with a 262,144 token context. At low reasoning effort, the next 4 turns completed the build in about 7 minutes and 18 seconds. The production build passed, although the JavaScript chunk triggered a size warning. All 8 model visible structural checks also passed. The result was Neon Rift, Station 0, built with Vite and Three.js. The game rendered, but combat feedback was hard to read, and the central rift was overexposed. We gave the same model a screenshot. In its visual pass, it added health bars for damaged enemies, dimmed the rift light and halo, and placed the wave banner on a darker background. The pass took 10 model turns and about 27 minutes and 54 seconds. A later disk check found temporary mismatches, so, with explicit approval, we replayed the model's saved writes exactly. No one rewrote the source by hand. After the repair, a separate post-run automated browser test used standard keyboard and mouse inputs. Movement, pointer lock, aiming, quick clicks, held fire, damage, scoring, and restart all responded. In one captured combat sequence, ammo fell from 30 to 24, the score increased by 10, and the kill count increased by 1. This was not a human playtest, and it was not part of the original model session. Post-run automated QA also found a problem in the Evaluator itself. It first reported 2 failures, but the test used the wrong arguments for the damage hook and the wrong state fields for restart. After correcting that contract, a test hook kill added 25 points exactly once. Restart reset health, ammo, score, kills, wave, and position. Game over and victory were visually distinct. Victory was reached through deterministic QA staging, not through a natural playthrough. In a separate 5-minute automated soak test, 4,090 ordinary keyboard and mouse inputs produced 2,245 observed state signature changes. The test used the visible restart control 19 times and logged no material runtime error. Across the initial build, interrupted recovery, 262K build and visual repair, the model completed 21 turns, totaling 59.45 minutes of request time. The bounded conclusion is that this one local Qwen deployment produced a small playable FPS after a documented failure and recovery. It does not demonstrate a natural 3-way victory, prove game balance or collision against every obstacle, or establish that this model is generally superior. The game is also limited to one arena with Simple Pursuit AI, with no audio, save system, touch controls, or gamepad support.